It's going. Here it goes.
There it goes.
Live. I think we're live. Maybe. Oh yeah, we are. Okay, there we go. It's going. So this is the first time that I've gone, I think, like live on my channel other than doing radio streams. And right now we're introducing Q. So
That's
Q.
Am I pointing? There you are. Found you.
You have to use both hands because if you use one, you point the wrong way. So Q, go ahead and tell everyone about who Q is.
Well, you can learn with me as I learn what I am. Yep, I'm Nathaniel Quist. I go by the letter Q. I work for Palo Alto Networks. I am a senior threat researcher. I work specifically on public cloud, so within the Prisma cloud set. So threats, types of things that are facing the public cloud. What are things that we see within the industry itself as a public cloud? Those are things that I'll be looking at. We put a bi-yearly report out. So every 2 years we do a spring and a fall report. We grab some of the latest information that we have based on this particular topic. This last topic was all infrastructure as code. So IAC technology templates, like things like Terraform and CloudFormation and even like Kubernetes YAML files. We looked at those things, those public types of public templates that are available, and then we just analyze them for what types of risks they have, what types of misconfigurations they might have. And unfortunately, we found like 64% of all of those publicly available templates, do something bad or open something that shouldn't be open, like SSH or RDP, or just expose the system just directly to the internet with no precautions, no security groups or anything like that. So those are some of the things that we've been looking at. Then we also take our clients that we have. I look at some of their data, some of their NetFlow data, some of their network traffic, some of what they have, and look for bad things in them, like types of malware, types of things like that. So it's kind of around all over the map. Cloud is it's both very broad and very narrow at the same time. So we kind of run in a lot of different directions. Really cool about Palo Alto is that I'm part of the Unit 42 team. Unit 42 is a threat intel team. We primarily our team looks particularly at malware threats that are facing infrastructures. So everything that comes from Unit 42 is pretty broad. So everything that comes from we don't ever attribute to specific nation states. We mostly look at like code families themselves or like malware family sets. Everything that comes from botnets to particular types of code families to all that stuff. I just bring the cloud aspect to it. So that's life in a nutshell.
For someone who's in the trenches of cloud, who has been able to build with it, engineer with it, secure it, analyze, assess, what would you say is the most fascinating thing about cloud today, since it, of course, is right now I guess it's a cornerstone of society these days?
Yeah, I mean, it's lots of talk about it. It's always accessible, right? I mean, it's when you have the data centers stuff, it's like we have a 99.99999% uptime. Cloud is 100% uptime. Or if it's not, you don't have an internet connection, right? So it's kind of the onus is on you if you can't connect to it. So cloud is very, very available. And then you look at the types of cloud providers that you have. I mean, they each have their own specificity, their own type of thing that they're better at than, say, another one. So the AWSs and the GCPs, AWS is really good at instances and just pulling systems up really quickly. GCP is really good at processing and large scale data, right? But they can both do each other's work, right? Just depends on how you want to architect it and how you want to look at it. So some of the coolest stuff that I think with cloud is that just how easy it is to put systems up there. And it's actually scarily easy because it's just, it's so easy that people just, push the buttons and then, boom, there's a system up there, and they're not really looking at where, from a security perspective, what might be wrong with that, or how you can make it better. But at the same time, it's like you have so much control over every little ounce and every little aspect of that particular little instance. You can change this tiny little bit of it, and you can make that one thing scale across 1,000 different systems. But if you make that one little thing wrong and then you scale it across 1,000 systems, you have that one little wrong thing across 1,000 different systems. So it's kind of like you have to know what you're looking at, and then you have to know what it is that you want to create in the first place, and how do you best secure it. So I think the cloud, like real clouds, I mean, they can go anywhere they want, right? I mean, they're really free. The cloud lets us just be free with what it is that we want to do. I mean, if you can think of it, you can build it, which is an awesome concept.
That's true too, because with cloud, it's become such a thing that there are free cloud resources. There are all kinds of paid cloud services. You can get like cloud assistants with like little AIs built into them that have done machine learning for certain tasks. Like, I mean, there's just all these things you can do in it. And nowadays, like we have containerization. Like, so what is it that really got you to discover cloud for yourself, to start learning these things? Because obviously you didn't just learn cloud yesterday and overnight. So like, how did you get to where you are?
It's been a process. I mean, so my history has been, I came from network, right? So network traffic. I had my first ground roots inside of sessionized NetFlow data, looking at how you can like build patterns on types of data relations, on types of applications that make specific patterns. Then eventually grew into, obviously get a hold of Wireshark, and you start taking apart all the packets and build Scapy and start making your own packets. And so I learned inside of network type traffic. Then when I started getting into logarithm and looking through that, it was more of like, how do I actually see how these types of systems are all connected to each other, and then how do they talk? So how can I see what this system is saying versus that system or that application, and how can I correlate all of those different pieces together to actually say, this is the story that happened, this is how that person went from this system to this system to this system, and this is how you can correlate that. Within cloud, I mean, when I first started hearing about cloud, it came from the event management aspect of it, and it was just CloudTrail and CloudWatch. I was like, well, these are weird, like cloudy, like logs and things. How do I get those and analyze them and look at them? So it kind of started with that. From that, it kind of moved into APIs. How can I get APIs and actually start, manipulating those and actually getting more logs from different API services and things of that nature. And they just kind of opened up the door to cloud. And then it was like AWS just kind of like opened the door, and I was just kind of like, wow, there's all these different services. Now you have Security Monkey, you have like all these different things that look at compliance for particular applications and are they configured properly. And I just started opening the doors to different little things. And how can you attack AWS? How can you defend AWS? How can you and so it just kind of opened the door like just really, really large. When I hired on with Palo Alto, I was actually hiring on with Redlock, which got acquired by Palo Alto a year ago. And so with Redlock, they gave me a little task to be like, okay, well, if you're going to do threat research in a cloud environment, what are some of the things that you would look at? And I was kind of like, well, because AWS is so easy to open, right, and just start running and just have a system that's up there running, I want to see if I can just find misconfigurations, because people are just going to throw systems out there like there is no tomorrow, and they're not going to think about security in any way with that. So I'm going to find systems that have default configurations, that have default username and passwords, that have default applications, that have no customization whatsoever. I'm just going to go find some. So I just went out and just started scanning around, and sure enough, it took me maybe 20 minutes, and I was like, well, there's a whole bunch of Elasticsearches, and there's a whole bunch of Cabanas, and there's a whole bunch of NGINXs, and I was just kind of like, well, there's all data now. Can I just happen to open these and just see what's inside of them? And so yeah, I just kind of walked in there. There was no password, there's no authentication, right? Those ones that did have passwords and authentications, I mean, they're just default passwords and configuration. So you just kind of try, well, what's the default password for this? And it's like, oh, well, sure enough, that gets me in. And so not like I'm being malicious or anything like that. I'm just seeing what the landscape is. And so I put together all of my findings, and I wrote this paper on it, and I gave it to the CISO for Redlock at the time. And I was just kind of like, this is what I found. This is a huge issue. because Red Luck at that time had just uncovered a whole bunch of Tesla systems from Tesla that were just up there and running, and they had a whole bunch of crypto mining software on them. And they just released that paper, and I was like, well, it's not hard to find because all these systems are just default, right? So anybody can just walk into it. If you can get a Showdown account, you're going to find all this stuff, So that's how it started. Here's the paper. This is what I would look at. This is the types of things that I would, would offer, and then that's kind of how I started going. But it took, because I didn't take any classes, right? I've taken lots of classes from malware reversing to network, like advanced network, IR studies, stuff like that. So it's I don't know if they're advanced. It said it was advanced. I don't know if it was advanced. But, yeah. So I've done a lot of different types of work, and so cloud just kind of presented this ability to take so many different topics. You can go from IR, you can go to the malware studies, you can go to network traffic, you can go to threat hunting, you can go to architecture and configuration. There's so many aspects that are all kind of bundled together, and most people are kind of like, well, cloud, it's like secure and stuff, and it's not. So I just kind of opened up the door and I just kind of like walked into it.
And so many good points. And if for those who are new to cloud or aren't really sure what it is who are watching, some things to know about cloud is that at the end of the day, if you want to have a lot of computing power, or you want to be able to have a computing ecosystem that can grow like a garden, which we call scaling otherwise, then we want to be able to have, say, like, if you look in those data centers with all those racks, you essentially cluster a whole bunch of hardware together and all these different things. And what that means is you have not just one computer that's running maybe an operating system or a single operating system or however have you, but like maybe hundreds or thousands or millions of computers or servers that work together to accomplish a single goal. And it's kind of like one mega computer made of a ton of smaller computers. So at the end of the day, that's like a really narrowed down explanation of cloud for those who are not sure what that is. So that brings me to some interesting questions that I have for you, actually.
Can I put something on top of that, though, what you just said?
Totally. Yes.
Okay. So it's infrastructure, right? So one thing that I always like to say, it's like the cloud is out there somewhere, wherever it is, but it's actually a data center. It's actually just a large data center, or it's a compilation of hundreds of different data centers that they're all, I guess you would say, sharing their resources. So they're sharing CPUs, they're sharing RAMs with what type of other application you want to put on top of it. So a cloud provider like AWS or GCP or Azure or Alibaba or DigitalOcean or all the different ones that you'll have, they provide the box. They say, this is the box, and we're going to cluster them all together, and you can have as many different CPUs or RAMs as you want to pay for, and we will charge you for the computation cycle of that data that you're going to use on it, right? So if you wanted to use one CPU and 1 gig of RAM, you can do that. It's free in most platforms, right? If you had an application that's only like that small. So they handle the infrastructure, they handle the hardware, they're going to do all the patching and all the management. It's a platform as a service for AWS. What then happens is if you want to put an application on top of that, or you want to run, say, a simple thing like NGINX or Apache or whatever, you're in charge of that application. You don't have to worry about the infrastructure that's writing on. You're just going to say, this application is what I'm going to control, and all the data that is derived from it or given to it, I'm going to facilitate that. So you're in charge of the application, they're in charge of the infrastructure and the platform. So there's basic.
Yeah, and this is pretty cool. So since this is our first live chat here on the channel, we actually have questions. So a question about from a student, basically, let's see. So a student has an associate cybersecurity degree, Security Plus, and some other certifications, and they are currently looking, and they've worked in technical type roles before, and they are currently looking for what type of cyber position would help them get into this sort of space.
Into cloud specifically?
Yeah, into cloud security, or just cloud in general for that matter.
Okay, so there are, without revealing all of my cards, I have a lot of certs. So I have a master's degree from SANS Institute. So I have a lot of certs that came with that. I'm not against certs. My preference is more about the factual degree, right? I wanted the knowledge, so I wanted the bachelor's, I wanted the master's. So I did that route. The certs are a big plus. Having said that, my mind is not so much geared specifically towards specific types of certs. I do know specifically that AWS and GCP both offer certifications both on infrastructure and on application management. So if you're looking at wanting to get into a cloud space, there's a couple different ways that I would go. I would look specifically towards infrastructure related architectures like schemas, things of that nature. If you're looking towards big data sort of aspects, you want to mess with just a lot of RDS or BigQuery for any of that. There are specific certs that will point you in that direction. Unfortunately, I don't know all of those off the top of my head, so my apologies. But infrastructure is a great way to go. Governance and compliance is also a great way to go. It gets you in the door and knows what it is, the things that you're going to be looking at from a security perspective. So I don't have the specific things. I can do some research and I could give them to you, and then you could like disseminate them if you wanted to do that.
Yeah, totally. And maybe I even make a video on that sometime, like how to get into cloud security, because I've had a couple people who've come by the channel who actually ended up getting cybersecurity jobs after watching the like Where to Begin series or whatever I made for the channel. Which I thought was pretty neat. And good question of like, what are the types of cyber analyst or what type of positions, he says, does cyber analyst get someone into a cloud type role? It depends on, I guess, where you go to be a cyber analyst, if you get exposure to infrastructure. And I think that's a good point that Q made, because it really does come down to if you understand how to work with infrastructure. And this segues down into there's some very basic fundamentals in like networking that are really worth knowing, like lateral movement, which kind of goes back to something Q was saying earlier, is with the cloud, with normal computers, if you have a connection that goes from computer to computer to computer and skips around, we call that lateral movement, like connections from node to node or computer to computer or system to system. But then in the cloud, we have a whole bunch of systems making kind of one system. So Q, how does lateral movement work in the cloud? I'm actually curious about that.
So, I mean, in much the same way as it works in a normal environment, right? So, inside of the cloud, let's take AWS, for example, or, I'll just say AWS just because it's the easiest to wrap your heads around. You have an infrastructure that you have. You create everything that a normal data center would have, right? So you have a internet gateway, right? And that is your access out to the internet, and everything from the internet has to go through that gateway into your infrastructure. You're going to make something called a VPC, or a virtual private connection. That is going to be like, I don't know the proper analogy. It's the way that you're going to initially distribute. Like, think of it as like the first initial router or modem that you have on your environment. It's going to make the forks for you, right? It's going to allow you to take the one IP address that you get from your internet gateway and be able to break it off into your individual IPs, right? From that, you'll be able to make all the different subnets that you'd ever want to make. You'd be able to make every type of infrastructure that you have. You're still going to make subnets the same way that we make subnets inside of a normal data center. And you can put systems, whatever system you want to have inside of that. On top of that, then you have the security aspects, or like the firewalls, right? So you'll call those security groups. And then that allows what type of communication you're going to allow into that particular VPC, and what type you're going to allow out of it. And you can also break that off farther into individual types of systems. Like, this system can only communicate to this other system, or something of that nature. You can break everything down to a pretty small finite degree. And the long and short of everything is you still have instances. All those instances writing inside of all of those particular VPCs, they will communicate just like a normal system. They'll have an IP address. You can make it IPv6, IPv4, whatever you want to make it, and it will communicate with another system on another IP address. Even inside of Kubernetes, which is like another system inside of another system and has a whole other network inside of it, they're still going to communicate to each other by IP addresses. So a lateral movement going from one application or one EC2 instance to another EC2 instance is still going to be a lateral movement, and they're still going to make that same connection.
So, yeah, that makes a lot of sense. And because I've been messing a lot with Raspberry Pi clusters lately, and clustering and trying different types of clusters, and orchestration's become a really fascinating thing to me lately. And I've been taking a look at their tools like Chef, their tools like Puppet. Have you played around with orchestration much?
So the most I've gotten done to orchestration is going to be more for like the Kubernetes aspect,
Sure.
where Chef and Puppet can be part of that. They primarily use something called Calico or something like that to help orchestrate. Kubernetes is a little bit different because it's more of like a dynamic fast on, fast off application container, right? So if a particular, like say you're hosting a web gateway or a web server, something like that, and all of a sudden you get crushed with traffic because someone's trying to, you say you're hosting an event, and it got really popular for like 5 minutes, and so like it needs to auto scale in order to handle that environment. Kubernetes will allow an individual container to pop up, and another one, until it meets demand. In order to handle the networking for those different containers that are popping up, it uses something called Calico or Weave or something of that particular network mesh framework to make the IP addresses work properly. It makes it a little bit different in that you have one IP address, and that one IP address has a whole bunch of different clusters behind it. So it'll use like combinations of ports and different kinds of sub IPs inside of that. But yeah, it's fascinating stuff. It really is.
Is Calico and Weave, are those also load balancers, or do those feature load balancing too? Or
yeah, they'll orchestrate how that communication goes. If one particular system is overrun or it's just handling a lot, it'll just auto orchestrate it down to another system.
Okay, that makes sense. Because for those who are a little less familiar with orchestration, all that good stuff, orchestration is just sort of just trying to keep things together and like in unison, in sync, and all that good stuff. And with cloud, if we have, say, as I was saying earlier, hundreds or even thousands or even millions of systems that are all supposed to work together, then we have to have a way to orchestrate them and keep them together, just like if we were to watch a symphony, which is pretty neat. And there is this sweet, cool called Kubernetes, which I only have been messing with it for maybe like the past 2 years or however, which is not for very long for me. But I guess what's your favorite cloud, I guess, architectural tool? Do you like Kubernetes the most, or do you have something else that you like to tinker with the most?
It's Kubernetes is I'm not tool agnostic, right? I'm pretty agnostic when it comes to tools. If you have a thing that works, then use that. Also, support is also a big thing. Kubernetes has a pretty good community support for that. You can have Kubernetes, and you can also do Docker Swarm. Docker Swarm is also a managed container orchestration tool as well. So you could do that. But Kubernetes, as far as industry goes, is it's pretty powerful. It's very commonly, very widely used. There are others, but I like Kubernetes. It's great. As far as tools for building infrastructure just within the cloud itself, I'm a huge fan of Terraform. I think Terraform is awesome. So
now tell us more about Terraform, because I think that's a pretty fascinating topic, and I bet the people who watch this stuff would probably think it's pretty cool too.
Yeah. So Terraform is it's a framework. You can call it a platform as well. Basically it's infrastructure as code, right? So as Nate was saying just a second ago, all those data centers with all those racks of servers and all that stuff, Terraform allows you to build all of that within script, right? So you can go to AWS or GCP or Azure, which is why I like Terraform. Because it can go across-platform, whatever tool, as long as it is an API connection to that tool or that platform, it'll communicate with it. So you can essentially build a Terraform template or infrastructure code, and you can take that from AWS and move it over to GCP. You will have to make changes, right? Because AWS has their own way of naming their types of resources, where GCP has another way of naming their resources. But essentially, you can take the same template, change some words around, do find and replace, and change all that, and then flip it over to another platform, which is cool. And I like being able to use the same language across multiple things. But Terraform is awesome. So instead of like individually saying, I want to make this internet gateway, and then I want to make this VPC off of it, and then I want to make these subnets off of that VPC, and then I want to make these security groups that only allow like port 22 and port 3389 into these particular subnets, and only want port 8080 on this particular subnet. Instead of building those all by hand, and every individual little EC2 instance or RDS instance or S3 bucket or whatever you want to make, you basically build it all into a code, and then you push Terraform apply, and it'll just run through and it'll build it all for you. So you can build an entire infrastructure that's like 20, 30, 40 different, as many different systems as you want, and it'll build it all automatically for you within, obviously a fraction of the time than you having to manually do it all. So it's an awesome tool. I love working on it. I have lab systems that I basically say I want this lab system in US West 2, and then I want to make the same lab system but with a different kind of tool tool at the end. I want to make it in US West 1 or US East 1. I just take the same infrastructure, just apply here and then apply there, and I have two infrastructures at the same time. I like it just for scalability and just being able to massively open things. So
that's one of the like architectural tools that kind of reminds me of, because you can use there's this tool called like Cloud Init that you can use with Terraform and all of that. Have you ever messed with Cloud Init tools?
Can't say I have, unfortunately.
Okay, because those are, I've been tinkering with those lately, and it's kind of interesting. It's if you're trying to create a whole bunch of images or like custom images, you can use this thing called Cloud Init for if you're trying to spin up a whole bunch of OSs at once, whether they're containerized or not. You can have this thing just automatically install preferred applications in whatever format that you prefer, and then it'll start with the master for Cloud Init, and then it'll just kind of maintain configurations. Awesome. And so it's kind of so what I've started experimenting with, because I was doing some pen testing with it, is if you go and set up a Cloud Init, and then you have configurations, and then you go and try to force change those configurations, or try to say even change a host name, right? Then
sure.
You reboot, and then if it's used in conjunction with an orchestration tool like Puppet or Chef or both, then if someone tries to make changes, then it'll automatically try to every 30 minutes try to make the changes back to what it's supposed to be.
Yeah, and just kind of breaks everything.
It's really confusing if you're engineering with it and someone didn't tell you that there's a Cloud Init configured, because you might go and try to go and use some other tool to manage configurations, and then this Cloud Init tool is like, nope. And you're like, I hate this.
I'm trying to make it off this template that you told me to make, man. So
yeah, it's pretty neat once you get it, but it's still, I don't know. But so what are some other tools aside from Terraform that you like to use for I guess setting up large clusters?
Well, I mentioned CloudFormation specifically for AWS. Kubernetes YAML files are pretty awesome if you want to make like Kubernetes a particular form. I guess I'm not sure of other ones that I can go off right off the top. Those are the ones I've been using lately, so those are fresh in my head. Yeah, I guess I can't really answer that question to a very large degree.
Sure. If you were to give someone security awareness advice on how to have cloud access in a more secure format, what would you tell everyone that they like? What are the top like 5 things that everyone must think about if you want to have more secure cloud access?
Think of IAC scanners and vulnerability scanners for your cloud templates. I think templates are the way to go. I mean, it's just the fastest way to make anything inside of inside of the cloud environment. So ways to scan those, looking for both misconfigurations and vulnerabilities of those systems. You might have a Docker image that is wanting to put up a particular application or a particular app, whatever it is that you want to do, and it might be an older version, even though it says the latest. Whatever, NGINX, colon latest, it might still be something in it, some vulnerability that was just discovered like last week or whatever. So being able to scan those systems, being able to get, your CVSS score on it, being able to know what type of things that you're exposing, it's a huge thing. Knowing your environment, just like a regular environment, data center, you have to know what you have. You have to know what systems you're running. So ways that you can actually audit and understand what your environment is telling you. To plug my own products, Prisma Cloud is a great tool. It's an API access directly into your cloud environment, and it actually is able to check what network connections your particular systems are making, what compliance violations that you're actually making within those cloud platforms. It'll tell you what type of user behavior that you're having, if you have something that's potentially shady or not. And if you have particular patternized data like crypto mining or DDoS events or things like that. There's a lot of that kind of right out of the box that is just, it only takes like literally 5 seconds to set up, just an API key, just put it into your Prisma Cloud, and then it's monitoring all of your cloud environment, which is great. Nice. Then bringing in, from a large architectural perspective, if you have a large pipeline that's using the cloud, you're probably going to do something like CI/CD, which is code in and code distributed type of infrastructure. So like things like Jenkins will use this sort of stuff, where you'll have like a template, or you have like a cloud system that you want to implement into production. It's first going to go in dev. You're going to test it in dev. Once it passes everything in dev, then it's going to move on into production and then be live there. Really implement security as early shifting left as you possibly can in the production cycle to really make sure that you are secure, and that the templates and the instances that you're going to be spinning up, thousands of, or literally millions in some cases, of these particular things, are free of error, free of misconfiguration. One thing that's really important to know with cloud is that you almost have to know what it is that you want to know, your goal, to such a degree that every step that's going to take to get it there. Know the process, know how it rolls through dev, how it rolls through production, how it rolls into real life, and then what types of risks that you have. So security in the cloud is, you have to be so much more like mind aware of what you have than even in a data center, because it can just, it spirals so quick and it opens up so fast that if you have a chink in the armor way at the beginning of planning that you didn't foresee, then that can just systemically roll out for a long time. So
yeah, upfront preparation is so important, and those are a lot of good points. And actually, does that tool use syslog by chance as well, or is it just API for data?
Which one? So Prisma Cloud?
Yeah, Prisma Cloud. That's
so it will write directly into whatever cloud platform's log that you have. So if you're in AWS, you can have it write directly into your CloudWatch bucket, or your cloud. We also have our own logging on the end that then you can also look into as well. That will then be delivered to whatever platform that you want to have. So it will do a sys out to something. So there's lots of ways to get the logs and monitoring out of that tool. Prisma's, it's good. Oh, also Prisma Cloud also does AIC scanning. So anytime that you actually have a template that you have, or if say you have a container that you want to just spin up like a Docker file or something like that, you can have it built into Prisma Cloud, where it'll automatically scan that and say, you have these errors, these misconfigurations in this particular tool. I won't deploy that to production until it gets resolved. So you can build that into your pipeline,
that makes a lot of sense.
Yeah.
And because the cloud, the interesting thing about the cloud is people love it because it increases accessibility of systems. But then, of course, it's almost like it's own worst enemy at the same time. It's like its best friend and its enemy.
It is. Yeah. I mean, it's a Goliath, right? It's a very large piece. And there's so many pieces that are inside of it. It's a lot to keep track of sometimes.
Yeah, definitely. And even trying to learn this stuff. So for someone who's just trying to learn this and they're trying to find some free resources and they're not really even sure if they like cloud, what are some, I guess, free resources that you've used, or things that you would recommend for anyone trying to find free resources?
I'm taking books out here, so hold on.
Oh, sure.
There are some, these are great. Okay. So there's a couple different books that that I picked up that I've been looking at pretty heavily lately. So one is hands-on AWS penetration testing with Kali Linux. So this is again more for pen testers. Those A teams. There's another one, pen testing Azure applications. So you have AWS and Azure, both pretty good books. GCP also has a pen testing for GCP book. Unfortunately, that one's not here yet. It's getting here. And then as far as languages go, so Python is very popular, very huge across all the different systems. Go is a big one, so Black Hat Go. This is a really cool book, gives you some really good ideas. Go is a pretty awesome language, and it's almost. If I could put my prophecy hat on, I think Go is going to be the language of the cloud as far as that goes. So
that makes sense.
Learn Python, learn Go, and you're going to know a lot of cloud things. So.
And so for Go, it has gained some like massive traction in the past few years because Python has a huge community of just a huge community. Point blank.
Yeah, no, Python's and Python's not going anywhere. It's going to be around for a long time. So.
And then Go, on the other hand, it started off as this thing that no one ever knew was, and then all of a sudden it's just like, hey, here I am with a massive community too,
yeah,
which kind of snuck up on me anyways. I didn't really see that coming, which is kind of neat. Looking at that more too later.
What's made Go really interesting? Well, Python's really cool because it's just so modular, right? I mean, it's a small code base. The scripts are just really tiny. It's easy to read. It's like super like natural language form, right? So it's really easy to build and read and all of that. Go is like a proper language, right? So it's going to be like your C, C++ and all that stuff, where it's actually like a foundational language where you can build binaries and things. Like, I mean, you can with Python, but Go is like all of that library is built into it together. So that makes your executable, your binary is going to be a much larger file because it has a lot of innate abilities already built into it. Cool thing about Go is that you can actually, there's like when it comes to encrypting and decrypting things, it's all just built into the tool itself. The nice thing about Go is it's fast. It's like made for multi-scaling. It's made for multi-processors. It's made for being able to do hypervisory, like just really nice applications that are quick and easy and move fast, which is great for cloud. And I think that's the biggest reason why Go took off so well, because we have the cloud to such a degree that you can have 37,000 processors if you need to have that many for an application, right? So so Go's an awesomely fast language. It's very powerful. It's very verbose. It's a little bit not as it's not as hard as like C, C++. It's like in between Python as far as usability and readability and writability, and then C++ is like over here. You have like Go. It's like in the middle as far as.
That's not too bad.
I think it's pretty good language. It's pretty fun.
So for that matter, if we're thinking about if it includes encryption, I guess.
Yeah, there's a lot of stuff in it. I mean, it's nice. It's like there's encryption. There's hold on, 1 second.
Because I've been trying to look for something that's a little faster for developing cryptography for cloud structures. Yeah. And it seems like Go might be better than because I was using Bash mostly for that, but you've used Bash before. You know how very manual, and then you have to build Bash scripts, and then those are not even as dynamic as Python. Well, in some cases they can be. I guess it depends on what you're doing with Bash. But when you're trying to do cryptography with Bash, you pretty much just have to pull like repos for like OpenSSL, keygen, and then find something to drop that into if you want to replicate it. But then if you ever have like mismatching keys, I don't know. But is Go a little easier to do cryptography with? Would you say?
I would say so. I mean, if it's going to be up to whatever. I mean, I know some wicked smart reversers that Python is everything, and they have all the libraries. They made their own custom libraries for their Python stuff and for their encryption and decryption stuff, and it's just. It works for them. So again, it's more of like what's comfortable for you as a person building something, and then what are the tools available. Go is a larger set, right? So your binary, your executable is going to be much larger because all of those libraries are already built into it. All of those functions already built into the core base, which makes it very modular, right? You can move it from from Windows to Linux to Mac environments. As long as it can read Go, it does everything. Where Python is like, if you don't have that particular library installed, no, good luck. You're not going to be able to run this thing. You have to like build all your requirements and all that stuff first. So Go is like all self-contained. You can just put this code right into that system, and as long as that system can read Go, that application is going to run without question. Where Python, you have to build your requirements first, or what have you. So
does Go play nicely with Terraform? Probably, I'd assume.
They're two different things, right? So you can just like you can evoke Terraform scripts and things like that with Python. You can do that with Go, all that. So Terraform is its own framework. It really resides outside of Python or Go.
That makes sense. That's one thing that I want to spend more time with, because I've read about it and I've never really messed with it. And after talking, I'm like, man, I need to go mess with Terraform.
That's the thing, man. It's like for anybody that's asking, like, how do you get into these things? It's really like I watched Greg, talk about on your show last.
Oh, sure.
And the big thing that he said, and I agree with Greg on almost all things. But one thing that he says that is really true is passion, right? If you have an idea and you want to go someplace with it, there is no limit in going there. So if you think that cloud is awesome, like I think cloud is awesome, and go there and you'll find it. You will find ways to do it. If you're in an organization that is starting to use cloud or has some cloud infrastructure, and you're in a security position or in an IT position or what have you, learn more about it. If you're in an IT scope, learn more about the infrastructure, learn how you build applications, learn how you can make that faster and that process easier. If you're in a security team, look at cloud. Am I pulling down all of the information that I need? Are applications logging properly? Or am I seeing insight into these systems? Do I actually have endpoint detection tools in my cloud systems? Or can I not do that, right? How am I securing my cloud systems? So in either direction, you have great resources and great ways to get there. From a free perspective, you can build like as much infrastructure as you want in AWS for free. You just build it. You can build users, you can build VPCs, you can build security groups, you can do it. It doesn't cost you anything because you're not using any CPU. As soon as you start using CPU, then they're going to start charging you for it. But if you don't mind using like micro systems, like only one CPU and one RAM, you can use those for free. So there's a lot of freeness out there. GCP has a $300 credit when you first start using it to, you spend $300 on Google to learn how to use Google Cloud. So there's, if it's something you want to do, there's so much resources, so much knowledge to be had from it.
And it's so night and day from like how it was even like 10 years ago. And I guess some people, 10 years sounds like a long time to some people, but like if we go back 10 years to like 2010, it's not that resources weren't there, but the sheer amount of availability of resources these days is rather incredible. And I just remember seeing like just the new bump from the Raspberry Pi Model 3 to the Raspberry Pi Model 4, because I'm an open source junkie. And I remember seeing Raspberry Pi 3, I saw Broadcom on it and I ran for the hills. I was like, Broadcom, I'm not touching this. And then of course they found out there's a vulnerability on the Wi-Fi chip on Raspberry Pi 3. So I'm like, I don't know. I just want some open source hardware that I can do things with and put whatever binary on that's not going to cause weird issues.
They always have weird issues. If you're an open source, you're either going to put that effort into that open source system to make it do what it is you're going to do, or if you're going to pay for it, you're going to pay for it, but it's going to do what you want it to do because you paid for it.
Totally. That's all very true. Because that you're right about, if you aren't using open source, then you get these pre-built, like paid for resources. And there is a benefit to that, especially like in the business space. Trying to do everything yourself in business doesn't make any sense, like almost at all. It's like
your boss is going to be coming down on you and being like, why isn't this made yet? It's like, well, I had to build this library and then I had to build this thing.
Yeah, it's like in technology, I feel like anything that you want to do think about how long you think it's going to take and maybe like multiply it by like 10. Be like, okay, it'll take 10 times longer than I think.
Star Trek, right? So Scotty would be like, he'd be like, Captain, this thing's gonna take, it's legit gonna take me like 2 hours to make. So he said, Captain, I'm gonna give you 4, and the captain says, well, you have 2, and he's like, well, that's what I thought it was gonna take anyway. So
it's like that. Because yeah, if you try to do other things other than just like one thing at a time, like so far as the business process goes, you're just not going to get anything done. So if you want to get a lot done, you like the more resources you can pay for, it's almost like a shortcut to just be able to focus, because you're already going to have to do endless amounts of work no matter how much you pay.
You're going to pay for it anyway, right? You're going to pay for the manpower to build it, or you're going to pay for the system to just do it for you anyway. So
it's totally true. And because like while I like open source, it's kind of funny. The reason why I like open source is because I like that I can spend a year doing things to it, and then after I've spent that year doing things to it, it keeps doing those things. But a lot of people also don't want to spend a year getting their open source resources like on point. And I remember like when I was at Logarithm, I remember there's this task that took like 8 months to do, and I was like, we can write scripts for this and make all.
I remember you doing that. I was like, I want to write a script for all this.
It was so mundane because it was literally, there would be something that you would spend, and I'm not joking, like maybe 2 months of data entry, which is fine. It's the nature of the beast when you're doing technical work. And but the thing is, things like data entry is so routine, you can just automate it. And so if you automate it, then you don't have to do these things anymore. And the cool thing about adding the cloud to that is then you can take your open source and throw it in the cloud, which before the cloud stuff, it's like... And for free.
I mean, it's really cool. I just want to make a comment. So Froggy Derp here said, I'm a long way from him, but now I have a battle plan. I'm glad you have a battle plan, and I started from ground zero like 2 years ago. So it's just like, at least when it comes to cloud stuff, right? So, you get there, right? So just know where you want to go and just go get it.
Totally. Yeah, you made a really big point right there. Is if you just take the time to figure out what you want, you could spend 1 year, 5 years just trying to figure out what you want. But as long as you focus on that first, then once you know what you want, you can just go get it. But if you don't know what you want, you'll spend years trying to figure that out. So because I've met people who they're like, I'm just going to get a bunch of jobs. I'm just going to work really hard. And then they just work. And then all of a sudden, like 5, 6, 7 years later, I hear the same thing over and over again when they don't have like a goal in mind. They're like, why did I do all this? And I did that too, which is why I'm also saying that, because I've done so many random things. It's like I did malware analysis, then I started working with like cloud before I went to Logarithm, which is why I was doing HA at Logarithm. I was like, oh, HA, yeah, I remember that. And so then Logarithm, I spent more time getting into like compliance, but I didn't really know what I wanted to do. I didn't have a goal when I was doing all this stuff. I was like, oh, you guys need this? Okay, I'll do that. And it's like, well, you need this? I'll do that. And then I just like worked myself into the ground. And then I'm like, what am I even doing? I don't even know what I'm doing anymore. And then finally you figure out what you want. And then it's easy when you do that. So my recommendation is to listen to Q right here, because if you just take the time to figure out what you want, I guarantee you can save even a decade of just milling around wondering what you're doing with your life. I promise you. What are some of your other like life advice inputs, Q? Because you've been through the ringer too. I know I've gone through things.
I have a history, right? So go back into my past, right? So one thing that I'm actually really proud of, in a weird sort of way, is that I spent 10 years in college getting a bachelor's degree. Because I spent 10 years doing that. I had a degree, I had a plan for 3 years, and then I decided I don't want to do that anymore my junior year in college. And I was like, this is a horrible idea. So I was doing acting and directing. I wanted to do the directing aspect of it. But I spent 3 years, and I finally looked at it, and I was just kind of like, the average salary of an actor is $7,000 a year. I don't want to do that, so I don't love it that much to do it. So I switched gears and I went to physics, and I was just kind of from acting to physics. I was like, okay, fine. So I did physics for a few years, and then I was kind of like, wait a minute, Calc 2 I still have 2 more. I have Calc 3 to go through, and then I have differential equations to go through. I don't like math this much, so I don't want to do that anymore. So, but it took 2 years to figure that out. Like, okay, fine. And then I went into computer graphics, computer motion effects, things of that nature. So I just started messing with 3D animation and all that stuff, really getting more into, computer hardware, nuts and bolts of how to make the computers work and building, because at that time, this was before, Toy Story 1 just came out, right? So it was like 3D effects were like, Toy Story is amazing, and then we didn't even get to the point where we're making like photorealistic things yet. So that was going out, and then all of that time, so now you start taking like those years, and then I ran out of money. And it was kind of like, because the student loans were kind of like, the government came to me, and they're kind of like, so, I'm really happy that you want to learn and everything like that, but, you've reached the limit of what the government's going to give you for student loans. And I was kind of like, oh, damn. So what am I going to do now? At this time, I was actually married and had a kid, and I'm kind of like, I should probably think of something to do with my life. So believe it or not, I joined the Army, and the Army was a cool experience. It's not for everybody. I'm going to say that right off the top of the bat. It's not for everybody. It was really good for me because, one, it paid off all my student loans, so that's awesome. And then I re-enlisted, and they gave me a GI Bill, so I got my master's degree. So that was cool. While I was in the military, I actually then finished my bachelor's degree because I was doing something of interest at the time, and it was computer security and forensics. Because at the time, when I was in the Army, I was attached to an NSA unit. I was working down in Texas, so I was working NSA mission with computer, network defense, so C&D work. So I was doing that, and I just kind of side-channeled my my day job with with getting a bachelor's degree in computer security forensics. So that's kind of how that happened. And so when it comes to computer security work, I just completely lucked right into it. I started out as a linguist, learned Russian and then Spanish. So great life skills to have from there. And then from those, I got into document translation, which led into email translation, which led into email header translation, started looking at IP addresses and how IP addresses communicate with other IP addresses and how emails get delivered. And that led into computer network defense. So that's how I got into this field sort of aspect. But during that entire time where I'm going from, skipping from step to step to step, trying to figure out what it is that I'm doing with life, my wife who was like amazingly, she's brilliant. She says, if you could wake up tomorrow and do anything you want to do, what is the thing that you'd want to do? And that was just kind of like, well, yeah, what would I want to do if I could just wake up and do anything? And then it just kind of turned out, so I just started following that. It's like, I want to do that because that's cool stuff. And I want to do that because that's cool stuff. And so that's always been my guide, like, what is cool. I'm a big fan of the grass is always greener, so go there. So, if the grass is greener, then go that way, and see what you find. You may get there and realize that, yeah, it may not be actually better than I thought it was, but at least you now know, and you had a journey to get there, so now you have something, right? So you just keep learning on those type of things. So that's my life advice is wake up tomorrow, you can do anything. What would it be? Go do it. And then if the grass is greener over there, go where the grass is greener. Not hard. So
I think that's outstanding advice and a funny observation for anyone who's been watching my channel for a while. So if we include myself, Q is now the third person who studied acting in college. So at some point,
I'm not a good actor. I'm a horrible actor. I think the reason I can't really lie. It's really hard for me to lie, and acting is just the ultimate, the ultimate thing of lying. So I'm like, okay, can't do it.
And the other part, like to go with that, is like advice wise, like yeah, like if there's something that sounds cool, like it may sound hard or it may sound impossible, but at the end of the day, you'd be shocked if you just went and then just started trying to do whatever sounds cool. You can actually do more than you probably thought you could. And another thing I've run into is, especially for those who are entrepreneurial and trying to figure out how to start their own thing and things like that, if you don't focus on doing something that you actually like, it sounds cheesy and it sounds like the cliche things on the movie, but I guarantee you can try doing things you don't like when running your own business. And like, you've heard of the concept of burnout. If you get a normal job, if you get burnt out, then you keep getting a salary when you show up to work burnt out for 8 hours and do nothing for 8 hours for like 2, 3, 4, 5 weeks. But if you're running your own thing, you better hope you like what you're doing, because whatever you don't like will just crash and burn to dust. I guarantee you. Now I've tried doing it and then watching other people do it. I'm like, oh, can anyone do that? I don't think so. Someone can prove me wrong. I really hope so. But so I had this thought. What was it? I mean, there's always so many thoughts. But anyways, so, like life is a strange thing like that. I guess one of the things I was thinking about is if you're the type of person who gets down on your background or down on your experiences, or think that you don't know as much as someone else, like at the end of the day, everyone has to start somewhere. Like,
I mean, you should have seen me like last week, because last week I was pissed, right? I was just so mad because I spent 2 weeks trying to build this, stupid honeypot system, and it wasn't working. And I'm around and around and around and around, and I just keep spinning, and I keep spinning, and I keep spinning. And my wife is looking at me going like, "Are you okay? Because you're mad." And I was kind of like, "No, I'm not okay," And I'm going through this, and finally she put up to it for like 2 or 3 days, and she's kind of like, "That's it. You're done. Just take a break. Don't do it anymore. Just stop." And I was like, I can't stop because I have to do it, and the pressure and all this stuff. And in my head was that, there's like that negativity sort of aspect where it was just kind of like, I'm not smart enough. I can't see it. I'm getting paid, a pretty good salary to do what it is that I do, so I better, produce. I better create things that are actually, good and worthwhile. So in my head was constantly like, I'm not good enough. I don't know enough. How can I learn more? How do I know more? How, and just berating and berating and berating. And so, knowing when to just stop and relax and look at a thing for what a thing is, and be like, I've never done this before. This thing that I was working on, it was stupid stuff around Google SSO stuff, but it's not stupid. Google SSO was awesome, but it was just like it didn't mean that I had to be so irate about it, right? Totally. Because it's something that I've never done before, so I'm going to do something I've never done before because I need to learn, right? So learning is a good thing. Every time I fail, I learn some way that didn't work, right? So it's good. Just realize where you are. That's all.
Definitely, and because even I run into that as when I do things, I'll sit there and get all anxious, and then I usually get really antisocial, and I get anxious, and I just disappear off the face of the planet. But then it's like, oh, I can't do this. Other people know so much more than me, and it's so easy to get locked in. And I don't know. Maybe there's someone out there who never gets locked in those patterns. Like, I couldn't say, but I know I do.
Yeah. I work with some of the smartest people I've ever met. I mean, I work with some like genius level people, and they're just
totally.
I'm in awe. I'm in shock that I was kind of like, how did you do that? Like, there's one guy that I work with. His name's Mike, and he was just like, he's like, yeah, I found a bypass through this tool, and it just but he found it through this like ridiculous like side channel like way of breaking a system, and it just like he was able to bypass it and it worked. I'm like, well, how did you do that? And he's like, well, I spent 96 hours finding it. And I was just like, that's insane. So
that's so it really is like that too, because especially it's at some point you have to start trying to compare yourself to who you were yesterday, because it's when you work in research spaces, it's kind of funny. People are like, Nathan, you're so smart, or they'll say like so and so smart, and then I'll go into the lab and be like, everyone's smarter than me.
I know, like I'm the dumbest person in this room.
Yeah. It's quite the opposite of like some people when they feel like maybe the smartest in the room. You really do go into a space of like other scientists or researchers, and you're like, I'm probably the dumbest person in this room, and it's really easy to do that.
Well, that person went to Johns Hopkins, and that person went to Harvard, and that person went to
Oh man, and it's so true. Golden question here. It says, did having a beard ever cause you issues?
in more ways than one. Yeah, but I guess from like a work perspective or just life perspective, because I get food in there all the time, and then like, I'm kissing my wife and I get like hair in there, and so.
Life challenges with beard.
But from work, no, the Army didn't let me have a beard, so there was that. I had a beard before I joined the Army. Joined the Army, I shaved it off, all that stuff. Every leave I got, I grew another one, and then shaved it off again. And then so when I left the Army, I just decided I'm never ever going to shave and have a beard forever. So it's never hurt me from a work perspective. I always try to keep it nice, right? I manicure it and I keep it good and all of that. But it's never hurt from work.
So what would be your beard care recommendations? Because lately I've been getting like beard care things because it's not like yours, but it still gets scraggly and has started having weird issues.
Moisturize. It's important to moisturize. Always.
Sure.
So I do two things. I have two different kinds of oil. I have one's called Maestro oil. It's just a natural beard oil you get from Target. And then there's also another one I use, almond oil. I'll do a combination of different things. So it depends on the washing regimen and all that stuff. Like if I use like a really heavy or a nasty shampoo or something like that really strips it really heavy, then I'll do a big layer of almond oil, cover that all up. And then I'll use a Maestro oil the next day and get that going. And then I'll use a beard balm of some sort. Always want to put your oils on before your beard balms. Because a beard balm acts like a kind of a coating. It like wraps around each little hair and provides a little armor for it.
Oh, sure.
If you put that on first, then the oil can't get into it. So put the oil on first and then put the beard balm on.
I've never tried almond oil before. I'm gonna have to check that out because, like I said before, the more I've been having, I'm like, I kind of like having something on my face. There's a thing to it, but then if you don't manage it, then you're right, it gets dry, and then you get like ingrown hairs, and then you start having like because it'll have like you have to like wash it so that it doesn't get like a smell of not washing it. But then if you wash it, then it gets dry. And like, it's like you can't win with the beard. But that answers quite a bit.
Yeah, you gotta keep it going because when you get to this length, it's really been like this length. It really hasn't gone any farther. This is pretty much the farthest I think my beard's going to grow. It's been this way for a few years. But yeah, it starts getting brittle and stuff like that. You can get a little bit longer by not having it not break. The only way to do that is oils and balms. So
skills.
You learn, right? If you didn't, I didn't know it. If they're there for a long time, I didn't do anything, right? I just left it normal, right? I didn't cut it, didn't do anything to it, and it was just all kind of scraggly, and I was like, this looks pretty sad. Should do something with it. So, and then I started doing something with it, and it actually got, funny. It got better, so it was weird. So
it works. Yeah, and it looks good, looking sharp, sharp as always.
I like your look. I mean, you have like this French debonair suave look sort of thing. I like that.
I get like weird patches where it like doesn't want to grow in places. It's like, what? I'm not even going to fill in all the way. I'm just going to be like, what? I'm not going to grow right here, and I'm not going to grow here either. I'm going to hate you.
You do the Tony Stark thing. You almost have that Tony Stark thing where you have that little thing right there.
It's true. I could just do the mustache thing too. Have you ever done just like straight mustache and tried to do like the curl?
So I got a pretty good mustache going right here, and I keep saying that I'm going to shave the beard off at some point and just do the mustache. So I've done a mustache before when I first joined the Army, or when I was in the Army and I'd shave my beard off like at the end of leave or something like that. I'd always leave the mustache for like a couple days, and then it was like my wife's like, no, get rid of that.
Oh, that's so funny. Yeah, it's it's all good stuff.
Your wife dictates quite a bit. I mean, I wouldn't have a beard if my wife didn't like it. So
I'm in the same boat because my wife, she's like, I'm fine with the beard. Actually, she likes the beard, so I'm like, that makes life simple. So I don't. Except for I try to get rid of the neck beard as much as possible when it's not growing too much. Because if you have like not long beard and then you just have like neck beard, then kind of. And then you get I get a lot of ingrown hairs down here. There you go. There's all the personal information about facial hair grooming. Just so everyone probably came here for this, right?
They came for this. They didn't want to hear about computers or clouds or anything. So.
Of course. But yeah, so well, so now that we've gone, it's about an hour so far. So Q, thanks for coming on. Do you have any like closing words for everyone before we go ahead and close the live stream for everyone? Do you have anything that you'd like to tell everyone, especially since you do have the beard skills, but you also have the cloud skills, and then you also have all these skills that you built even before I met you? So what's your last words that you'd like to share today? Because you'll probably be on here again if you enjoy this.
Yeah, no, I mean I'll keep doing this. It's awesome. I love it. So,
It's fun.
you know, I don't know. I mean, I'm a very you know, I get very passionate about things, and I love learning. You know, I'm not a person that likes to sit. If I'm sitting for a couple hours and not doing anything, then I get mad. You know, so I always have to do something. You know, I mean, I can sit still for a while, and meditation is awesome. So definitely meditate is a good thing. Do it as often as you can. 30 minutes is pretty much all you need. If you can do like an hour session on a weekend, that's awesome. It really helps frame where your brain is and what you're thinking about. So meditation is a great thing. Other things that are awesome is pick up a puzzle. I love wire puzzles. Always pick up wire puzzles. Now, you remember my desk at Logarithm? I have.
Oh, definitely.
You know, so I love wire puzzles. I absolutely love puzzles. You know, because I like what it does. I like how you think about things. I like, you know, trying to figure out a solution to something. And then I approach cloud that way as well, or any job that I do is what can I learn from this, and how can I improve, and how can I make it better, or something like that. So if there's one advice that I can give to people is always just keep trying, keep to better, trying to better yourself, trying to learn something new, trying to just do something. I'm trying to learn how to play the banjo right now, because I think that would be awesome. And I've had a banjo for several years, and it's hard, and it's frustrating and all that stuff. But I know that I'll be better for it. So just do something that you think is better for you. And I think that's the only advice I can give you.
And there you have it. So go do something. Do something to better yourself. And even if it doesn't better you, just do it anyways. So just go do something. It's so funny that the Shia LaBeouf thing is like, do it. I don't know if you've seen that YouTube video, but look up Shia LaBeouf, do it, and watch that for some inspiration. Remember, Shia LaBeouf, do it. And then also there's another one. What's it called? There's another Shia LaBeouf.
Well, I just know of his music video. It's like Shia LaBeouf is running through the woods, and he's like,
yes, that awesome. One. Shia LaBeouf is running through the woods. He remembered it. So look up Shia LaBeouf is running through the woods too, and then look up Shia LaBeouf, do it, and then just go do something. It will inspire you and motivate you. So, anyways, thanks for coming on, Q. And then until the next time, we'll see you. And thanks everyone for joining our first live stream. So that was pretty fun. So thank you, everyone.
Awesome.